All right, knocking on the door. It's a customer that has a zone system. She has 2 zones. She's been having a list of issues, and we're just doing a second opinion here. See how we can help her out. I'm going to go to this downstairs thermostat, and we're just going to drop the temperature down to get that zone to call. Go to the upstairs thermostat. We're going to drop the temperature down on that a couple degrees, get it to come on. And we're going to the air handler, which is in a closet off this bathroom, and we're going to go ahead and look at what we have here. Pretty basic setup. Looks like they have a fresh air UV. It's in the return. I'm going to pull this filter door access off. We want to first look at our evaporator coil. It's always good to make sure that we're exchanging good airflow. So we're just looking for debris, anything like that. I like to use a cell phone, just kind of record what's going on in there. A lot of times that just tells us everything we need to know, especially if we have to just show that to a customer. I'm trying to see if there is a light on. Doesn't really seem like there's much light coming out of that for a UV. We're going to look at this video. All right, so the video pretty much shows the evaporator coil looking up. It's obviously a better angle than we can get, and you know, allows us to blow up the image too, so we can get a better perspective on what those coil fins look like. I also like to do another inspection, just physically look at it with a flashlight. You can see there, that coil looks much dirtier when you look at it on that angle. It's hard to get the camera in there so you can see what I'm seeing here, but again, that video just really helps out a lot. Other things that I'm looking at here is, you know, the air moving back to the return. Obviously just checking to make sure there's no water standing in the drain line. It's always good just because it's right there. But put that filter door back on. Put those screws back in it. It's very easy to leave this stuff out when you're doing an inspection, so always try to put things back as we go. Good practice. And I'm looking at that return. That's going to be the very next thing. So it looks pretty funny. It looks like there's no metal elbow in there, so it's just kind of folded, and that's blocking about 40% of that airflow. So that is not good. Yeah, and you can see that it's an 18-inch in diameter. You can see where it's coming up into the ceiling. I'm looking at that supply trunk line now. That supply trunk line has no elbow in that. It's very malleable. So we already have a good, clear indication of what's going on there. Looking on the other side, there's this duct that's going downstairs that's not on any zone. It's just coming right off the supply plenum. So have to look into that a little bit. Let's look at the zone. We can see that it's a pretty standard Honeywell 2-zone board. You see the wires coming down to it. Always like to count my wires, make sure there's nothing additional. Kind of would just indicate that a wire is abandoned, you know. So always want to try to map that out so you can get a good perspective on what's going on there. Okay, a little messy, could definitely have been done better. I don't like how these wires are going into the cabinet there. They can easily get chafed. There's no garment or anything there to protect it, you know, from getting skint. Okay, I'm looking at the wiring there. There's absolutely no discharge air temperature sensor hooked to it, and so there's no sensor for that zone to know that we've reached a low or high limit for that zone to work correctly. And so that's not good. That's definitely something we're also going to notate. So a couple things already to notate, just sitting here in this closet. Okay, I'm going to go ahead and put the cover back on. Like I mentioned earlier, just kind of put things back so you don't accidentally leave something off. All right, that's pretty much all we need to do in this closet here. So we're going to go ahead and turn off the light and exit out of there. That zone board, the return duct, and of course the supply duct issue that has no damper on it. So we're going to go out to that outdoor unit. Here it is. Okay, good. Everything's running. We'll go ahead and pull those caps off. Go out to my truck. I'm going to go ahead and grab what I'm going to need, which is obviously my gauges. All right, so we're going to go ahead and hook up our suction and discharge, or I'm sorry, suction and liquid line. Okay. Always good to purge those out a little bit. We don't want to put any non-condensables in our system. It's always good practice to hook them up right, purge those hoses. As we hook these up, always want to make sure you have a good connection so you're reading pressure. You want to hook up your clamps, make sure that you're on a good piece of copper, wiggle it around, make sure you're making a good connection there. And you don't want to be on any type of solder joints or anything like that, any kind of couplings. All right, well, obviously want to see what are we, R22, 410A, R32, 454B. So want to identify what type of refrigerant we're using, so when we turn on these Espins, we can put it on the right setting. And so we're good there. And want to analyze these pressures. I know it's kind of hard to see right this second what these pressures are, but you know, first glance I don't see anything crazy. So we're going to look at a couple things, what our subcool value should be. Okay, we're looking for that, and then basically we want to compare that subcool to that superheat, knowing that both zones are wide open. Couple things that I see already is we have a 12.7 superheat and a 3.5 subcool, so that's a little low of a subcool, but that superheat's pretty low already. And a couple things that are going to make that low are obviously the return ducting. So if we were to take that kink out, that superheat would actually go higher. And if we did add more refrigerant and not do that, then that superheat's going to go lower. So we can't really charge this thing properly until we get that superheat where it needs to be and enough airflow on that evaporator. You see we're down to 9.2 already. So it's moving now that it's ran a little bit longer. This is pretty much accurate. I'm going to close off that downstairs zone. We'll just go ahead and bring that temperature up to satisfy that zone, and that damper is going to shut off, leaving only one zone running. And we'll give that a couple minutes of running, and then we should be able to see a new value. And I'm expecting the superheat to go lower, and it's obviously going to correspond. And this is one of the concerns that I have, is if filters start to get dirty, if we close one zone off, anything like that, we're going to wind up having liquid go back to the compressor, and we're going to lose oil. We're going to look at that pumping ratio, just taking the liquid and the suction, divide them into each other. We have a 2.1 pumping ratio, which is not a very strong pumping ratio. So if we wind up losing oil, then we're also going to wind up having mechanical failures on this compressor. You can see we're already down to 8.3 on that superheat. So if we were to charge this thing properly, we're going to have an issue with that superheat going even lower. So some of the things need to change on that upstairs air handler, involving airflow and a safety switch like that discharge air temperature sensor and a bypass, and then we could charge this thing up properly. So we got to first establish that first before we go any further. So that's our report. We're going to go share that with the customer, Thanks for staying tuned. Like our channel, subscribe if you haven't done so already. We appreciate all your support.